So in this exercise, we're giving a resistive network, and we know all the values of the resistors except for this one, R. And we're asked to calculate what that value of R is. Now we are given what the input resistance is. Input resistance is 1 ohm. So we should be able to use that information to determine what the value of R is. So let's see how we do that. So the first thing we want to do is just reduce this network. And the first thing we notice right off the bat is that if we take this path right here, this is the way the current would flow, and we can see that neither of the 4 ohm resistors is a path to travel. So in other words, those two 4 ohm resistors are shorted out. So in a sense, they have no bearing on the circuit whatsoever. So that being the case, we can just simply remove them. So it's like these aren't even here because they will not be utilized because the current will always take the path of least resistance. And so in this case, that would be the short circuit. And so it'll never go through the 4 ohms. So that one's gone, and then this one is gone as well. So this simplifies our circuit a good bit right here. So now we want to come back and we'll notice that this resistor and this resistor, they share the same input and the same output. So this means that they're in parallel. So we can replace both of those resistors with one resistor. And so we'll call that new resistor, or we'll calculate that new resistance as saying that it's R in parallel with 1 ohm. And so to get that, that's going to be R times 1 over R plus 1, which is basically just R over R plus 1. So then we can replace those two resistors with the one resistor, R1. So let me clean this up a little bit. Remember, this part's gone. All of this is gone. So we don't have to consider this part anymore because we're replacing all this with one resistor. And so that's new value for this resistor will be R over R plus 1. Okay, so we've reduced this quite a bit. So let's look a little further. So now we see that this resistor and this resistor are in series. So that being the case, we can come back and say that this new R is going to be R. It's going to be R over R plus 1 plus 2. Okay, so that's what we can replace those two with. So let's go ahead and do that. So in this case, we won't need this anymore at all. And we won't need this anymore, as we're going to have a new value for that. And so what happens here then is we just connect over. We just connect over here. And now our new value for this resistor is R over R plus 1 plus 2. Okay, so we're getting closer. So now we want to notice that we have this resistor and this resistor in parallel. So let's come down and see if we can reduce those two. So that means we have the one resistor, which is R over R plus 1 plus 2 in parallel with 1 ohm. And so what that means then is we'll have R over R plus 1 plus 2, and that's going to be times 1. And then we'll we'll have R over R plus 1 plus 2 plus 1. And so if we simplify this out, we'll have R over R plus 1 plus 2, and then that'll be over R over R plus 1 plus 3. Okay, so that's the new value for that. So now we can get rid of, excuse me, I hit the wrong thing there. So now we can get rid of all of this, because we're going to replace it with one resistor again. And so this new resistor here will have a value, and let's rewrite this again. So we can simplify this a little more and make it easier. We can multiply with the top and the bottom by R plus 1. So when we do that, we will get R plus 2 times R plus 1. That'll be over R plus 3 times R plus 1. And when we multiply that out, we'll have 2R plus another R will be 3R plus 2. And then we'll have 3R plus another R, which will be 4R plus 3. So this resistor up here is going to then be 3R plus 2 over 4R plus 3. All right, so now one last step to get us back to Rn. And to do that, we're going to see here that we have these two resistors here are just in series. And so that's simple enough. Then that'll be 3R plus 2 over 4R plus 3 plus 4/15. So that's the second resistor. And this is going to be equal to, this just gets down to one last resistor, so that means that's equal to Rn. But we're told up here that Rn is equal to 1 ohm, so we can set that equal to 1. So now, if we subtract 4/15 from both sides, we will have 3R plus 2 over 4R plus 3. And that's equal to 1 minus 4 over 15, which will be 11 over 15. So now we can cross multiply. We have one equation, one unknown. So if we multiply 15 times this one, so that'll be 15 times 3R plus 2. And that's going to be equal to this guy cross multiplied times this one. So that's going to be 11 times 4R plus 3. And so this will be 45R, just multiplying out, plus 30. That's going to be equal to 44R plus 33. And so if we subtract 44R from both sides, we'll get R. And if we subtract 30 from both sides, we will get 3. So that means that our unknown resistor has got to be 3 ohms. So if we go back to our original diagram here, this value would be 3 ohms right there.